Welcome to day 32 of our course, where we explore the advanced features of modern programming languages. Today we will be discussing coroutines, async, await, metaprogramming, reflection, and introspection, some of the most powerful tools available in modern languages to enhance performance, readability, and flexibility in your code. Let's start with coroutines, async, await, and concurrency. Coroutines allow functions to pause and resume execution without blocking threads. This is especially useful for tasks like I/O operations, networking, or event-driven programming. In languages like Python, Kotlin, C Sharp, and JavaScript, coroutines help manage asynchronous tasks without needing to deal with complicated callback mechanisms. Async await is a feature that simplifies asynchronous programming. It makes the code more readable and avoids the complexity of callbacks by allowing developers to write asynchronous code in a synchronous manner. And when we talk about concurrency, we are referring to the ability to execute multiple tasks simultaneously. This allows for more efficient use of system resources and better performance. Go's coroutines and Python's Essentio are great examples of concurrency in action. Concurrency is a key feature of modern programming languages. It involves executing tasks concurrently without blocking the main program execution. While concurrency does not necessarily mean parallel execution, it allows multiple tasks to progress independently, which helps with resource utilization and performance. Languages like Go with its lightweight Go routines and Python with which uses Asyncio for asynchronous tasks provide tools to implement concurrency effectively. It's a critical feature for large-scale applications that require responsiveness and efficient resource management. Now let's dive into metaprogramming. This is a powerful feature where the code can manipulate other code at runtime or even generate new code. There are two main types of metaprogramming: compile time and runtime. At compile time, metaprogramming allows for the creation of templates or generic code. For example, in C++, templates lets you write code that works for any data type. At runtime, languages like Python and Ruby allow for more dynamic code manipulation, such as creating new classes or methods. The key benefit of metaprogramming is the increased flexibility it provides. It can write less boilerplate code and make your programs more adaptable. Metaprogramming is widely used in frameworks and libraries to adapt code dynamically based on the user's need. For instance, in Ruby on Rails, metaprogramming is used to build domain-specific languages (DSLs), which are mini languages for specific tasks, making the code cleaner and more readable. Another application of metaprogramming is in code generation, where parts of the program can be created dynamically based on the environment or user inputs. This reduces the need for repetitive code, making the development process more efficient. Let's move on to reflection and introspection. Reflection is the ability of a program to inspect and modify its own structure at runtime. It allows developers to dynamically load classes, methods, and attributes. Introspection, a related concept, focuses on examining the properties of an object. For example, in Python, the dir function can be used to inspect an object's attributes and methods. These features are often used in frameworks that need to adjust their behavior dynamically based on the objects they are working with. Next, we have type interference, which allows programming languages to automatically deduce the type of a variable based on its assigned value. Languages like Kotlin, TypeScript, and Rust all use type inference to make the code cleaner and less verbose. For example, Kotlin allows you to declare a variable without specifying its type, and it will infer the correct type based on the assigned value. This not only reduces redundancy but also improves code readability. Pattern matching is another advanced feature that allows you to match values against patterns or types. It makes conditional logic more expensive and readable. In languages like Python, JavaScript, and Scala, pattern matching provides a more intuitive way to handle complex conditions. For instance, Python's match statement, introduced in version 3.10, allows you to match variables against patterns directly, making code much more elegant compared to traditional if-else or switch statements. Let's talk about memory management, particularly in languages like Rust. Rust is known for its unique approach to memory management, which does not rely on garbage collection. Instead, it uses ownership, borrowing, and lifetimes to ensure memory safety at compile time. This approach prevents common issues like memory leaks and race conditions, ensuring that developers can write high performance applications without worrying about manual memory management. However, it does require more careful programming, making it more challenging for developers new to the language. With these advanced features like coroutines, metaprogramming, and memory management offer significant benefits that are trade-offs. The primary advantage is that these features allow for more efficient, flexible, and readable code. However, they can also increase complexity and introduce performance overhead, such as with reflection or dynamic typing. Moreover, some of these features, like Rust's memory management model, have a steeper learning curve. Developers need to balance the use of these features based on the specific requirements of their projects. In conclusion, modern programming languages provide a wide array of advanced features that can drastically improve the quality and performance of your code. From coroutines and async/await for concurrency to metaprogramming and reflection for dynamic behavior, these tools give developers a high degree of flexibility and control over their programs. Mastering these features will enable you to write more efficient, scalable, and maintainable software. However, it's important to understand when and how to use them to avoid overcomplicating your code. Thank you for joining me today. I hope you have a deeper understanding of advanced programming features like coroutines, metaprogrammings, and reflection. If you have any questions or would like to dive deeper into any topic, feel free to reach out. See you in the next session.